Hello everyone, welcome back to Via Digitally. In the continuation with operators in Python, today we will be discussing bitwise operators. Before going into this video, please subscribe our channel, hit the bell icon. Coming to bitwise operators, there are 6 types of bitwise operators in Python. They are bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, bitwise right shift and bitwise left shift. So this is the table. Here we are going to see how the operator is symbolized in Python language and how we write the syntax, means how we write two operands and one operator like bitwise operator. Here this is the table. How here we are seeing, let us see how each operator works one by one. But before discussing all these operators, first let me introduce you all like binary numbers. Binary numbers are also the number representation types where computers will use them usually. If we see outside world, like in our real life, we usually use decimal numbers, right? Like 0, 1, 2, 3. This is our numbers. But your machines don't understand our decimal numbers. They convert these decimals to binary. See here in this table, there are numbers from 0 to 15 in decimal in the right of the table. Coming to the left of the table, there are binary numbers. See, 0 is represented as 0, 1 is represented as 1, but 2 is represented as 1 0, 3 is represented as 1 1. As the weight of the decimal number is increasing, the number of bits in the binary number is also increasing. If you see the change in the number of bits, firstly there are 1 bit, next there are 2 bits, next there are 4 bits, next there are 5 bits, 6 bits, so on. Like this we'll be having in binary numbers. Then how do we write actually, like how do we convert from decimal to binary numbers in generally? Let us see, let me take you back to your first or second standard where you will be learning numbers, right? Like how to write big numbers using powers of 10, like units place, tens place, hundreds place, thousands place, lakhs, 10 lakhs, like that, right? See here, if we want to represent a number in decimal number, the digits we are going to use are from 0 to 9. We know, right, since the childhood. In the given slide, I am giving you two examples like 1066. How I am going to make 1066 in decimal number system? Always the units place carries the place value as 1, that is equals to 10 power 0, and tens place is 10, that is 10 power 1, and hundreds place is 10 square, and thousands place is 10 cube. So whenever we multiply this number into its corresponding place weight, and number into corresponding place weight, and number into corresponding place weight, and sum of all this, we are going to get the original number, right? Like we are simply multiplying the digit into its place weight and summing all the products so that we are getting the equivalent number. Similarly here, like 1940 is given, like 1 into 1000, 9 into 100, 4 into 10, 0 into 1. If we sum up all these things, we are going to get 1940. So coming here into binary number system, here also we have as similar as in the decimal number system, in binary also we do have place values. Like there we have 10 power 0, 10 power 1, 10 power 2, right? Here we are going to replace 10 with 2, that is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Then what are their place values are equivalent? There we have 1, 10, 100, 1000, 10,000, but here 1, 2, 4, 8, 16, 32 means these all are the powers of 2. Then if I write a number, for example 10110001, then what is its equivalent value in decimal? How do we know that? There what we did, we just multiplied the digit into its corresponding value, place value, right? Here also the same thing. Here the digit into its corresponding place value, digit into its corresponding place value. So in the given example, like 1011001 to the base 2, if I want that to convert into decimal, simply like 1 into 64, 1 into 16, 1 into 8, 1 into 1. Anyways, if we multiply with 0, that product is 0. So we are going to consider the bits wherever the 1 is available, we are going to multiply its value with corresponding place value. Then if I do like that, I am just getting the number as 89. Means 1011001 to the base 2 is equals to 89 in decimal number. So this is a small introduction like how binary numbers are came into existence. Next, There is one more concept of binary numbers. You should get some doubt, right? Like I can represent from 0 to some infinite numbers in binary numbers. Then how to deal with negative numbers, means how your machines are dealing with negative numbers. You should get taught by yourself, like how negative numbers are represented by in the computers. If you can see here, you all knows, right? Like 1 is 0 0 1, 2 is 0 1 0, 3 is 0 0 1 1. Then how negative numbers are represented means, the numbers where we are going to represent, there will be having the first most significant bit as 1 for the negative numbers. And how we are going to do here, right? Coming back to this slide, for example, this is also this is simple binary number. If I want to convert this into 2's complement format, what I am going to do here is I am simply take, instead of plus 64, we are going to multiply this first bit with minus 64. And if you do minus 64, what happens here? Instead of 1 into 64, 1 into minus 64 means the overall product and the sum of entire products you are going to get as some negative number, that is in the 2's complement form. So if you want to know more about these things, you can just go through some digital electronic basics there. But up to now, still these things are enough, like what are decimal numbers, what are binary numbers, what are their place values, and what are 2's complement formats. These all are enough till now. So there is a standard table which represent all the characters we use in any programming language, like null character, space character, like special symbols, at the rate, hashtag, dollar symbol, percentage, whatnot, everything, digits, greater than, less than, colon, semicolon, capital letters, small letters, everything we do have some standard decimal number, some standard binary code, some standard hexadecimal code, and octal codes. Means for any programming language, if we need to design, we need to follow some certain standards. That standards are nothing but ASCII table standards. Means here we are going to represent any characters using some binary number or some decimal number or any number. Like it is a standard format, everyone must follow this. So if you can see here, like 0 is equivalent to the decimal 48, means in the ASCII table its number is 48. So similarly, in capital A is 65, and here small a is 97, and you can see here some special characters are there. And see here, like space is denoted as 32, means its ASCII number is 32. And here we have many special symbols here, and here we have special characters like tab space, backspace. These all are things where we are going to use in our programmings. So this is one of the reference table, no need to by heart, but we need to have some idea on alphabets, means like lower and uppercase both, and numbers we need to just remember them. Next, here we have the bitwise operators in Python. See here we have 6 types of bitwise operators, namely they are bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift and right shift. Then what is the use of bitwise operators? Bitwise operators are basically used to compare the binary numbers. Here you are getting right why I introduced the binary numbers, complementary numbers, and ASCII table there. Means if we perform some operations on some numbers or some alphabets, how we are going to generate these things. Watch this video very clearly and thoroughly. Try to understand what are ASCII codes, what are binary numbers and complementary numbers. Because using bitwise operations, we are going to get some alphabet or some number or some special characters as listed in ASCII table, right? Either one of them will be getting as output each and every time. Then coming to bitwise operators in Python, as I said, there were 6, like bitwise AND, bitwise OR, bitwise XOR, and NOT, left shift and right shift. In the upcoming video, I will be teaching you how these bitwise operators will work by real-time coding in my IDLE. Till then, please subscribing us, hit the bell icon. Thank you for watching.